So question 12 says solve the exponential equation, express irrational solutions in exact form. So if 8 to the negative x equals 2.6. So again, notice how, x is probably not going to be a friendly number because the right-hand side is 2.6. So how do we go about doing this algebraically? Well, to solve for x algebraically, I can't use the same base because I don't know off the top of my head of how to change this to an 8 and raise it to an exponent that's going to give me 8, or 2.6, I should say. So this becomes hard because I can't actually change 2.6 to have a base of 8. If I could, then I wouldn't really need all of this other algebra. But this algebra really helps me do this a lot easier. Now, the strategy is, since I can't change the bases to the same base, we're going to use the property of equality and take either the natural log or the common log of each side. I think the book likes the natural log, so I'm going to just use the natural log. So we have this 8 to the negative x equals 2.6. What I can do is, again, remember the property of equality says whatever you do one side, you can do the other side, and it's still going to be a true statement. So I'm going to take the natural log of 8 to the negative x. Again, you could use any log you want. I'm just going to keep it simple, natural log. And I'm going to have the natural log of 2.6 over here. Now, what happens here is we can apply the property of logarithms to solve for x. So remember, if x is an exponent of a log, this actually can become a coefficient out in front. So this allows me to bring the negative x out in front and write this as negative x natural log of 8 equals the natural log of 2.6. So then to get x by itself, I need to get rid of the negative and the natural log of x. So in other words, if I divide by a negative natural log of 8, and if I do that on both sides, a negative natural log of 8, that'll enable me to get x by itself. So the negatives will divide out, become a 1. The natural log of 8 will divide out, become a 1. So that just leaves me with 1x, or we can just write this as x equals then. Instead of leaving the negative on the bottom, I like to move the negative to the top. So it's going to be the natural log of, keep writing some funky symbol there. So this is going to be the natural log of 2.6 divided by the natural log of 8. Now, remember, you can't write this as subtraction because of, I do have a quotient, but to be subtraction, you'd have to have the natural log of 2.6 over 8 like that, but this is not the same thing. So don't get that confused. This quotient is still a quotient. You can't change it to subtraction. That's not a property of logarithms. So our exact answer is going to be that. So in our solution set, it's actually going to be the natural log of, do a little wrinkle there. So the natural log of 2.6 over the natural log of 8. That's going to be the exact answer. So if I do change that to a decimal, so if I type that to the calculator as the negative natural log of 2.6 divided by the natural log of 8, this will give me the actual answer. So back in my day, we'd have to use tables. So now the calculator's all got that figured out for us. So notice how this answer is going to be irrational, which means we have to round it. So this is actually going to be little squiggly lines. So this is going to approximate, if I round it to 3 decimal places, that'd be negative 0.459. So that 9 actually rounds up. So this is going to be actually negative 0.460. So that 59 actually moves up to a 60. So that would be my answer, rounding it to 3 decimal places. Now, again, if I wanted to verify it using a calculator, I could graph y equals 8 to the negative x minus 2.6. So I can bring this over and set it to 0. So if I graph y equals 8 to the negative x, and then subtract the 2.6, if I graph that, we do see a point of intersection. So if I hit second, calculate, and do 0, I need a left bound to start with, so I got to be left. So that looks left, hit enter. I have to do a right bound. That looks right of that x-intercept. Hit enter again, and notice that we did get negative 0.4595, or that rounds up to negative 4.60. So it does get verified on the calculator. But again, what they want is the exact answer, so you have to leave it in the form of negative natural log of 2.6 over the natural log of 8 if you're using the natural logarithm. Or if you use the common logarithm, that should also be acceptable.